saltwater issues and preventions. Here's the thing about taking your drone to the beach. The ocean is absolutely beautiful for aerial shots, but that sea breeze is carrying an invisible, destructive enemy. Very often, people bring their drones to the beach, and whether they actually fly the drone or just set it on the table, salt residue in the air deposits itself on the drone's body. Because of the drone body's open architecture, salt seeps directly into the circuit board. Unlike a camera, which is almost completely sealed, the drone circuitry behind the shell of the drone cover is open and can attract a salt residue. In fact, the electronics and circuit boards act like a total magnet for this stuff. You don't even have to crash into the water to ruin your drone. Just sitting on that beach table, the fine, misty salt air is quietly coating the high RPM motor bearings, the delicate copper windings, and the exposed pins of your electronic speed controllers. Salt is an incredible electrical conductor, so when it dries and crystallizes inside that open frame, it creates invisible bridges across your circuits. The next time you turn it on, electricity jumps where it shouldn't, causing an instant short circuit that can permanently fry your flying tripod. When you bring a DJI drone to a coastal environment, the salty air creates several hidden chain reaction problems under the hood. Here are 4 other related saltwater situations that happen when a drone visits the beach. The magnetic motor traps. The beach breeze doesn't just carry salt, it carries microscopic sand particles mixed with sea spray. Because your drone's brushless motors rely on powerful internal magnets to spin, they act like a vacuum for this debris. The salt mist coats the copper windings inside the motor bells, while the magnetic field pulls abrasive sand directly into the high RPM bearings, leading to an instant crunchy grind. 2. Galvanic dissimilar metal corrosion. Your drone is built using a mix of different metals, copper on the circuit boards, aluminum in the structural screws or heat sinks, and the steel in the motor shafts. When a salt residue and coastal humidity settle between these metals, they trigger a chemical reaction called galvanic corrosion. One metal essentially starts sacrificing itself to the other, causing rapid pitting, rusting, and the structural failure at the joint connections. 3. Antenna and signal degradation. The internal antennas and receiver modules rely on clean, uninhibited metal connections to talk to your remote controller across long distances. A fine layer of salt air crystallization over the internal antenna terminals disrupts this high-frequency telemetry. This can cause sudden, unexplainable signal drops, video static, or even a total loss of control right over the water. You don't have to ban yourself from the beach entirely. You just need a solid defense plan to minimize the disaster. First, treat the beach like a hazardous zone. Never take off or land directly from the sand because the wind from the propellers will whip up a salt and sand storm right into those open vents. Use a proper landing pad. Second, you finish your day at the beach, do a deep exterior detox. Take a microfiber cloth, slightly dampened with distilled water or isopropyl alcohol, and carefully wipe down the outer shell and arms to neutralize the surface. Finally, grab a can of compressed air or a high-powered hand blower and aggressively blast out the motor bells and open vents. You want to blow away that moist, salty air before it has a chance to sit in your bag, evaporate, and lock up your motors with permanent rust. A little bit of proactive cleaning takes less than 5 minutes, but it's the difference between keeping your beautiful drone pristine or turning it into a very expensive beach souvenir. Happy flying at the beach.